Today we're going to take a close look at Jupyter Notebooks for .NET using F# and how you can start your notebooks quickly using ServiceStack tooling. Jupyter is an exciting initiative to support an open standards, language-agnostic interactive computing platform. It provides a highly productive environment for exploring problems in scientific computing, especially among the core three languages of Julia, Python, and R, which is where it gets the Jupyter name. Being language agnostic by design, significant progress has been made to support running other languages as interactive notebooks. NET Interactive is a tool for .NET Core that's made it possible to use the F# language to write your notebooks running in a Jupyter environment. To leverage this platform better for ServiceStack services, we've added the ability to generate working F# notebooks that integrate directly with your specific ServiceStack host and service using the ServiceStack X tool. This enables F# .NET developers to have all the advantages of fast iteration loops that Jupyter and .NET Interactive can provide, while also generating all the plumbing to start working with the data straight away, all in the language you know best. To walk through an example, let's have a look at working locally with JupyterLab, which is Jupyter's next-generation web-based development environment designed around maintaining an entire workspace of notebooks in a powerful web UI. However, before we get started, you'll need a few things installed. Python 3.7 or higher, along with the pip package manager, the latest .NET 5 SDK, and the ServiceStack X tool. If you don't have the ServiceStack X tool installed, you can install it using the command .NET tool install -gx. And then before our system is ready to run Jupyter Notebooks, we're going to install 3 additional pieces of software. First, we want to install JupyterLab itself using the command pip install JupyterLab. Once completed, we can install the .NET Interactive tool using the command .NET tool install -g Microsoft.NET-Interactive. .NET Interactive is the basis for the compute engines that Jupyter will use as kernels. However, JupyterLab doesn't yet know about these kernels, so we will need to register them with Jupyter itself. Thankfully, .NET Interactive provides the following command to do this: .NET Interactive Jupyter install. Once this command has finished, we will want to verify that the kernels are installed and ready to use using the command Jupyter kernel spec list. This should show your default Python kernel as well as 3 new .NET kernels: .NET C#, .NET F#, and .NET PowerShell. Now that our Jupyter environment is set up, let's jump into JupyterLab. JupyterLab mounts the local folder it is run from, so you want to run this command from a new notebooks folder, as this will be where we're going to create some F# notebooks. You can start JupyterLab by now running the command jupyter-lab. The command will open up a new browser window showing JupyterLab running locally. To make sure everything is working, let's do a Hello World notebook. Click New F# notebook, and in the first cell, we're going to use print function Hello World, which should be written to the output below the cell. Now that we know .NET Interactive and Jupyter are working well together, let's move on to an example using data from a ServiceStack service. We're going to use the COVID Vaccination Watch hosted demo and plot vaccination rates in the US by state. The host URL for this demo can be found at the GitHub repository under ServiceStack apps /COVID Vaccination Watch. Navigating to the hosted demo and looking at the metadata URL, we can see that there are 2 request endpoints: get locations, which returns all the valid locations to filter by, and query vaccination rates, which is the auto query endpoint that returns us the vaccination rate data. To jumpstart the process, we can use the ServiceStack X tool to generate a working F# notebook specific to the COVID Vaccination Watch host and the query vaccination rates endpoint. Using the command from our notebook directory, we can run xjupyter-f#, the base URL of our ServiceStack host, space the request DTO name of the service we're interested in. Now the file is generated, we can have a look at our running JupyterLab interface, and the new file has been detected and is in the File Explorer on the left. Opening the notebook, we can see 4 cells. The first cell is used to set up the required NuGet libraries, declare the required DTO classes, and initialize our JSON service client with the specific ServiceStack host. The second cell queries our service and returns a strongly typed response. This is because the JSON service client knows that the request DTO has declared an iReturn type in the generated DTOs, so there is no guesswork to what data is returned, and we get the same type safety in our notebook as we do in any other ServiceStack client integration. The third cell renders a HTML table view of the data in the response, and the fourth cell a console-friendly version of the same table. We can see that without specifying a location, we are getting the result in alphabetical order. Changing the request to specify the location of Arizona, we can see that those displayed results also change. Now, while there were quite a few steps involved setting up our Jupyter environment, once it's up and running, every time we want to integrate with a new service, the ServiceStack X tool provides us a starting point with all the plumbing code done for us so we can focus on working with the data. Expanding on this example, let's use that data and visualize the vaccination rate using a NuGet library called Plotly.net. Plotly.net provides functions for generating and rendering Plotly.js charts using .NET. This kind of library is ideal for use in notebooks where outputs are a core part of being able to iterate quickly, so we want to make the notebooks as expressive as we can with the least amount of effort as possible. Adding a new cell to our notebook, we are going to do the following steps to visualize our data. Import the required Plotly.net NuGet dependencies using the #r syntax. Declare our using statements, transform the data into matching lists of primitive types for each axis of the chart, and finally generate the point chart and provide some basic axis labels. And finally, once that is done, we can use the display function, passing in the chart to render the results. It's clear to see all the different ways notebooks and Jupyter can make exploratory tasks more engaging and easier to do, but sometimes setting up your machine to iterate this way can be a bit time consuming and making your notebooks harder for others to run and see the same results. These troubles with repeatability can cause a lot of friction in a team just trying to run each other's notebooks. Thankfully, the Jupyter team has been addressing this problem as well with a technology called Binder and Binder Hub, which utilize Docker and Kubernetes to build images based on Git repositories and run the Jupyter environment in a container. Even better still, mybinder.org, which uses these technologies, provides a free way to run notebooks straight from a public GitHub repository. Combining this with the ability to generate the same working F# notebooks with just a web interface, and we have a pattern of repeatability and easy setup to enable quick collaboration that otherwise would be missed if a complex local installation is required. First, we'll start by creating our own public GitHub repository, which MyBinder will use to launch our own workspace container. Cloning the repository locally, we are going to add a Docker file that supports working with .NET Jupyter notebooks in a MyBinder environment. We've created a mix template to create this Docker file by using the command xmix docker-jupyter that can be run from the root of your local repository. Next, we'll create a notebooks directory so we can generate a notebook that integrates with the COVID vaccination watch service. We could use the xjupyter F# method, but instead we're going to use instant client apps. This will be more straightforward if someone wants to contribute a notebook to your repository in a pull request from a separate branch and still use MyBinder to show it working for your review. The contributor won't need to install the ServiceStack X tool locally just to generate a file, since they can do it straight from their browser. Navigating to apps.servicestack.net, providing the base URL of the ServiceStack service, choosing the F# language, and selecting from the available endpoints, you'll have the option to download the generated notebook near the bottom right. Saving this file locally in your notebook folder in your repository and pushing the changes to GitHub, we now have everything we need to run the notebook using the GitHub repository and the MyBinder service. Opening mybinder.org, we can provide your GitHub repository URL, specify the branch or leave it as the default head, and launch your container. This will likely take a minute before it is ready to use, as the service needs to build your Docker image and launch your container. Opening it up, we can run the 4 generated cells and see the data from the vaccination watch service, adding the same visualization cell, and we can get the same graph as the locally hosted notebook. We didn't have to spin up our own servers, and others contributing to your repository can read, test, run, and even commit updated code without leaving the browser. All this while you and your contributors get a working typed end-to-end notebook fetching and displaying data from a specific ServiceStack host. All the infrastructure is provided for you thanks to MyBinder, and your notebooks is ready to work with the data you need. Jupyter's interactive computing tools are getting better and better for .NET developers. It creates a great interactive way of not only writing but sharing code in a way that's collaborative and engaging. Having your data hosted in ServiceStack services enables you to lower the barrier of entry to these amazing tools by automating the plumbing to get typed end-to-end clients in any of the 9 supported languages. This saves time and effort so you and your users can get the most from your valuable data sources. With thanks to initiatives like Jupyter, .NET Interactive, and MyBinder, it's never been easier to try out these new ways of running your F# code. That's it for this video. I hope it's been useful, and thanks for watching.